Assalamu alaikum. Today we have a question on curvilinear motion. We have two particles, A and B, particle A, particle B, start at the origin and travel in opposite directions along the circular path at constant speeds as shown. So we have particle A going this way at 0.7 meter per second and particle B going this way at 1.5 meter per second. Determine in 2 seconds the displacement along the path of each particle, the position vector to each particle, and finally the shortest distance between the particles. Okay, now to start with, let us see what do we have and what can we do. First of all, we have the speed of each particle given and it's constant, right? And we want to find the displacement in 2 seconds. We can use from kinematics the displacement velocity time relation, which is the final position equal the initial position plus velocity times time. Okay, and now both of the particles here start at point O, so this is my origin, right? So at this point here I simply have 0 0, x is 0 and y is 0. So okay, so the initial position is 0, right? So we have now this is equal to vt. For particle A, the final position xf would be the velocity, which is 0.7 times the time, 2 seconds. So we will have 1.4 meter. And for B, the final position would be the speed, which is 1.5 times 2, 3 meters. Okay, so these are the displacements for each particle from the origin, right? Before we proceed to to section B of this question, I would like to highlight that we talk about here an arc, right? So here these particles are constrained to move along this arc. So now, in fact, this value here for the final displacement or position is in fact the length of that arc, right? So this is like OA, and the 3 meter is OB. Okay. Okay. Now, why I'm mentioning this? Because now, if we look at the second question here, the position vector to each particle, I want to find what is the position vector for particle A. Now, let me ask you this question: how can we go from point O to point A, right? In terms of x and y. Now, in terms of the x and y, let me draw this here. Let me say this is the A, point A, and here this is point O. Okay, let me make this a little bit longer to be just like the question. Okay, so this point O. Okay, so now to go to this point here, I can think about this as the following. I'm going to go up in the y direction this much, then I'm going to go to the right this much, and this way I will reach point O, point A, I mean from point O, but now I'm moving along the axis x and y. So now here, let me highlight that here, maybe in orange. So I will go from here to there, okay, and then from here to there. Now if I can find these lengths here, I will be able to write the position vector. Okay, so now let me try to do this. I'll call this position vector for particle A. Let me call it ROA. Okay, equals. Now to go from point O to point A, as we said, I'm going to go up this way and then I'll go to the right that much. So now, but notice the following here. Here I'm having some angle, right? Okay, now here we have an angle theta. Let me call it theta A. Okay. Right, now what about this whole length here? How much do we have here? Notice that this from here to there, this is simply the radius. So this whole length is just the 5 meter. Okay, so this is 5 meter is the same as this one, right? So just a circle. Okay, so that here is simply 5 meter from here to there. But now I'm only looking at this, right? I'm only going to go up this much. So if this is 5 meter, what about this here? This length here, if you look at that, we have here a right triangle. Okay, and this distance here simply is 5 cosine theta, right? So now this one here, let me make it in maybe in blue. This is here, this is 5 cosine theta a. So now how much would be the remaining part? This is the one that we highlighted in orange. This one here would be simply 5 minus 5 cosine theta a, right? Okay, so now what do we have? I want to calculate this theta, right? How can we find that? Now remember what I said. I said that these distances here we have found before, I mean the displacement, is simply the length of the arc, right? If I use this relation here, written as this, S equal rho times theta, where rho is the radius of curvature, in this case it's just the radius of the circle, and theta here is the angle in radians. This S here in fact is the arc length, right? I used X here, right, because I have used the famous kinematic relation, but you know this X here is the same as S. So I can now, before we find OA, the position vector, I can say XA is equal to the rho theta A, and XB equal to the rho theta B. And now I can find theta. Theta A here would be simply XA, we have found it to be 1.4, and the radius of curvature, which is the radius of the circle here, is just 5. And here we'll get the answer here in radians. I got 0.28 radian. And here theta B is simply 3 over 5, would be 0.6 radian. Okay. Of course, you can convert that if you want to degrees. If you multiply that by 180 divided by pi, you will get the answer in degrees. But you can leave it like that in radians. But remember, if you leave it in radians, you need to put the mode in the calculator to be radians, right? Okay. Right. So now I'm ready to write the position vector. This here simply, I mean going in the horizontal direction, this is simply 5 sine theta, right? So here I have 5 sine 0.28 I hat, and this is here simply is 5 minus 5 cosine 0.28. So let me write here plus 5 minus 5 cosine 0.28 j hat. Okay, so we can evaluate that. So here I got 1.382 I hat plus 0.1947 j hat. Okay, so that's the position vector for OA. Let us do now the position vector for OB, for particle B. Now we can use the same argument here. You know, I want to go from point O to point B. So now I'm going to, let me highlight that here on the same picture we have, because here I have some space. So now I want to go up this much, right? Then I'm going to go to the left this time, right? So now remember here, I'm moving in the positive y direction, but now here I'm moving in the negative x direction. So here we will have negative x component, right? Okay, let me just clear this because I need some space. Okay, so I'll leave that. I'll leave these formulas. Okay, so our OB now simply here minus 5 sine 0.6 I hat, okay, plus now 5 minus 5 cos 0.6 and j hat. Now if you do this, I found the position vector negative 2.823. Okay, sorry, let me just rewrite this. 2.823 I hat plus 0.8733 j hat. And now that's the position vector for OB. Of course, here we can add the units here in meter, and this as well also here in meter. Okay, so that answers part B. Now part C, the shortest distance between the particles. Now how do we find this? How do you calculate the shortest distance? If you have the position vector, now you can use simply the distance formula. So that part was part B, that part A. Now part C, the distance formula says the distance between 2 points simply is equal to the square root x2 minus x1 square plus y2 minus y1 square, right? Equals, of course, it doesn't really matter which one is 2, which one is 1. I'll take this to be x1 and this is to be x2. Okay, but as I said, it doesn't really matter because we are taking the square. So now putting this, I will have negative 2.823 minus the x component for OA 1.382 square plus, now y2 is the one for the OB, which is 0.87333 minus 0.1947 and square. Okay, so if you put that on the calculator, here I got this answer to 3 significant figures, 4.26 meter. Okay, so that's the answers for this last part. I hope you found this video useful and we learned something new. Please support this channel by liking the video and sharing the videos you think that are useful to you, and let us know in the comments if you have questions or suggestions, or if you want me to solve a certain or explain a certain concept. Thank you very much and wishing you all good luck.